Okay, here's a couple of good exponential function questions. It says the number of farms, certain area, decreased. So it started with 93,000 in 1950. Let me write that. 1950, there were 93,512. And then in 1995, there were only 28,954. Assume an exponential, find the value of k, write an exponential function. Okay, so we just have to find k. Okay, so p of t equals p0 e to the k times t. This is the n number, so that'll be this one. So 28,954 equals the start number, 93,512. E to the k I don't know. And it did this, that looks like 45 years. Okay, so let me do that on, I guess I'll divide both sides by 93,512, 93,512. Okay, so then I get 2854 over 93,512 equals e to the k times 45. And then change into the log form, log base e of 28,954. You could come up with that number if you want, but doing it this way just gives you improved accuracy. Equals k times 45. You divide both sides by 45. Let me do that on decimals. Okay. Graphing calculator. I gotta move it a bit. Oops. Okay, here we go. So I've got to go ln of 28,954 divided by 93,512. Close my bracket. Divided by 45. Okay, so my k value is equal to negative 0.0260529. So, to write my growth or decrease function, I'll just write the general formula again. And what I need to do is plug in for this and plug in for this and leave everything else the same. So, the number of farms after a specific amount of time is equal to the one that they start with was 93,512. E, my k value is there. Oh, it looks like they round to 3 decimal places, so I'll do that. Negative 0.026 times t. So that's what I would get. And it looks like it's that one. Oh, they didn't plug in the P0. Yeah, to write as that function, usually you would write in what your initial term was, but they put P0 for all of them. Anyway, that's the one I would pick. Here's another similar question, but this is a two-stepper. So you have to first find the increase amount. You need to find k, so how much it's increasing by, and then use k. Okay, so population after a given time, population that you start with, e to the k times t. So they say initially it has 10,000, so that's P0. If its population declines to 4,000, oh, it's going down. So it ends up at 4,000, okay? E to the k I don't know, and it does that in 4 hours times 4. Okay, divide both sides by 10,000. So 4,000 divided by 10,000. I should be able to do that in my head. Equals e to the k times 4. So it would be, I think, 2 over 5, or 0.4. Equals e to the k times 4. Change to log form of 0.4 is equal to k. And now let's figure that out on decimals. Okay, I forgot what my numbers were. Okay. Here we go. Log of 0.4. Ln, I should say ln of 0.4. Okay. So my k value is negative 0.91629. Okay, now it says, what will the population be at the end of 6 hours? So what I need to do is write my formula again. Let me write that down. So P of t equals P0 e to the k times t. And they want to know what the population is after 6 hours. So I'm going to plug in a 6 everywhere I see a t. I'll use the same initial amount of bacteria, E. Now I can use my K value, negative 0.91629 times 6. That's how long they want to know. Okay, back to decimals. So 10,000 E to the bracket negative 0.91629. Never bad to throw in a couple extra numbers there. Times 6. There. So after 6 hours, boy, that's going down real quick. Got to make sure I plugged in everything right. I think I did. So 40.96, or call it 41. Well, let's see what their answers are. Nothing anywhere close to my answer. Assume exponential model. Starts with 10,000, 4,000, 0.4 log. Oh, my k value is wrong. I forgot to divide. This was equal to 4. I needed to divide that by 4. So my k value is wrong. That's good. It's good to make mistakes and then fix them. So let's go to decimals here. So this answer here has to be divided by 4. There, that's better. So my k value will be negative 0.2290726. So then on the next step, I just have to change that. 2290726. Yeah, there we go. So 7952, close to 8,000. Do they have that as an answer? They don't have that either. Okay, what did I do wrong? 10,000 E. Oh, I forgot to times that one by 6. It's late at night. I forgot to times it by the time. I didn't, so they're 2,529. I should have written that whole thing again. So P of 6 is equal to 10,000 E to the negative 0.2290726 times 6. So I'm getting with that 25, 29.82. So let's see what they have. Do they have one of those? 2530. I got to go with that one. All right, hopefully that helps you out, and see some common mistakes that might happen. Even I made that. It was nice that I was able to figure out what my problem was. Hopefully you saw my problem as you were doing the video, and you were yelling, "Hey, you forgot to divide by 4." All right, hopefully that helps.